Good afternoon, class. Here's chapter 3, derivatives, section 3.4, the product and quotient rules. We covered the derivatives and rates of change, the derivatives as a function, basic differentiation formulas, and now the product and quotient rules, reminding you that if you have a function, given a function y equals f of x, and a point a comma f of a, the slope of a secant line PQ is the average rate of change of y with respect to x, rise over run. So you have 2 points. Calculate the slope as delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x. If we look at this one, the way it's given, f of x minus f of a over x minus a. If we look at this format, and this is a, and the distance of h is the run, we get to a plus h, then this point has coordinates a plus h and f of a plus h. We get f of a plus h minus f of a over h. And let's say this is b, therefore this is b f of b minus f of a over b minus a. All of them refer to the same thing. Now, PQ, the blue line represents a secant line. If we approach P, it gives rise to a red line known as a tangent. So the tangent line is the limiting position of the secant line PQ. As Q approaches P, a tangent line is a line that touches a curve at a specific point without crossing. Now, therefore, what is the slope of a tangent line when you have 1 point? It's the instantaneous rate of change. You can look at this one and say the limit as Q approaches P, so limit of M of PQ as Q approaches P. You look at this one, you can say limit of f of x minus f of a over x minus a as x approaches a. Or this one, the limit of f of a plus h minus f of a over h as h approaches 0. They all mean the same thing. And we call M or f prime of a the slope of a tangent line. Various formats to write the equation of a line. More specifically, we're going to use the point slope. Let's say this point, y minus y1 becomes y minus f of a. M is f prime of a. X minus x of 1 becomes x minus a. You can memorize that, or just go with the point slope. That's even easier. In general, if this is x and f of x, and this is x plus h, f of x plus delta x, f of x plus h, then f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0, the differentiation operation, the differentiation formula. And now, the product and quotient rules, let's remind everybody dy dx, by definition, is the limit of delta y over delta x as delta x approaches 0, or f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. The derivative of x is 1. The constant multiple says if you're taking the derivative of c times f of x, you can take the c out, and the sum and difference say that the derivative of f of x plus minus g of x is the derivative of f of x plus minus the derivative of g of x, which means just differentiate term by term. Some rules we looked at, starting with the power rule. As a result of that, the derivative of a constant is 0, the derivative of kx is k. And then more rules, the derivative of e to the power of x is itself. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tan x is secant squared. The derivative of cotangent x is minus cosecant squared. The derivative of secant x is secant x tan x. And the derivative of cosecant x is negative cosecant x cotangent x. The product and quotient rules, if f and g are differentiable, the derivative of f of x times g of x is f prime of x g of x plus g prime of x f of x. And the derivative of f of x over g of x is f prime of x g of x minus g prime of x f of x over g of x squared. And I like to go with the shorthand notation. It speeds up the process of remembering it and applying it. Now, one thing again quickly I want to mention, the order by which I write it. is maybe slightly different than the way some of you have seen, and I do it on purpose, so it becomes easy to memorize the quotient rule. Fg prime is f prime g plus g prime. F over g prime, use the same thing, you put a negative in between. F prime g minus g prime f over g squared, that's why. And now the product rule, by analogy with the sum and difference rules, one may be under the assumption that the derivative of a product is the product of the derivative, which is not the case. Let's look at a couple of simple examples. For example, we can use this simple case that if f of x is x, the derivative is 1. If g of x is x squared, we know the derivative is 2x. This is by the power rule. And if we multiply these two, obviously we get x cubed, and the derivative is 3x squared. So in other words, we already know what the derivative is. But if we go with the same analogy as we did here, we may be under the assumption that it's f prime g prime 1 times 2x, which is not the case. However, so we proved in essence, this doesn't work, because if you want to prove something doesn't work, one example is good enough. So fg prime is not equal to f prime g prime. However, the methodology that we use here and the shorthand notation, fg prime is f prime g plus g prime f. Now f prime is 1 times g is x squared, and g prime is 2x, f is x, 2x times x. So it's x squared and 2x squared. They do add up to 3x squared, and it does work. Now, I'm going to give you this example, and what I want you to do is to do it both ways. Number one, the best methodology is to distribute, simplify, collect like terms, use the power rule, differentiate. What do we mean by both ways? Imagine it's just the product of two things, f times g, and do it by the product rule. That's what I want you to do as well, okay? So you do this at home for practice to make sure it works. And now, the proof of the product rule, again, the shorthand notation, fg prime is f prime g plus g prime f. And I'm going to remind you that the definition of the limit is used here. The f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. So let capital F of x be the product of f and g. So we are going to go with capital F prime. So we're going to replace the lowercase f with capital F. And now what is capital F of x plus h? F of x plus h times g of x plus h. What is capital F of x? Just the same thing. And to do this, we're going to use a trick. We're going to add and subtract f of x plus h times g of x. So in between, we're going to add and subtract this piece. So first we subtract, then we add. Why do we do that? We're going to look at this piece and this piece separately in the following manner. Just look at this piece with the h in the denominator, of course. I hope you see that f of x plus h is in common, comes out, and you get g of x plus h minus f of x minus g of x, I mean. And this one, what's in common? G of x comes out. You get f of x plus h minus f of x. This is GA. Okay, there's a type. Now, we are going to use the limit laws and apply the limit to the first piece, limit of f of x plus h as h approaches 0. The second piece, the limit of g of x plus h minus g of x over h as h approaches 0. This one and this one, just using the limit laws. So if you apply the limit here, this is just the f function. This is the derivative of g. This is the g prime. This is the g function. This is f prime. And so we have f g prime plus, this is a plus sign, g f prime. Now again, I hope you see gf prime or f prime g is the same. I put it in a different order for the sake of the quotient rule. So they are identical. We just proved that. So I hope everybody's fine with that. Now let's take a look at this example, everybody. And this is the product rule, differentiate, do not simplify. And to use the product rule, let's notice is the product of two pieces. Of course, we are going, we don't want to distribute, we want to go with the product rule. Let's call them f times u. So according to this, we need f prime. That means 4x cubed with the minus 6x squared times g, just the blue function, 3x squared minus 5x, plus g prime, 6x minus 5, times f, the red function, x to the power of 4 minus 2x cubed minus 7. And please understand, this is the reason I said actually don't simplify. I want to emphasize this is the only calculus step. However, this is not finished. This needs a couple more, maybe 3 or 4 more steps to finish, and you want to finish it at home. I'm going to go over this concept one more time. Your digital platform may accept this as the final answer, but this is not the final answer. You have to finish it. Okay. So the same thing for the exam. You have to finish this to get full credit. Now, if h of x is x times e to the power of x, find h prime and h double prime. So first and foremost, notice is the product of x and e to the power of x. So I'm going to put a raised dot between the two, meaning it's f times g. I'm going to call this one f. I'm going to call this g. And therefore, I'm going to use the product rule on this. So I need f prime, which is 1, times g, which is e to the power of x. Again, I'm going to write the formulas from the memory, and I'm going to apply them. I know, again, some of you have learned ddx of this, ddx of that. You really don't need that. If you write this formula and follow it, so according to this formula, you need f prime, which is 1 times g. Now you need g prime. So you call this g. So this is itself, e to the power of x, times f, which is x. And of course, this is not a finished product. As far as I'm concerned, we factor e to the power of x out. We get 1 plus x. X plus 1 makes no difference. And now to get to h double prime, I have to differentiate this. And this is, again, using the product rule, f times g. So I'm going to call this one f and this one g. So again, I'm going to apply the product rule. According to that, I need f prime, which is e to the power of x, times g, which is 1 plus x, or x plus 1. And now g prime plus g prime is just 1 times f, which is e to the power of x. Now, if I factor the e to the power of x out, I get x plus 1 and 1, which is x plus 2, and I'm done. What about this one? Y equals x squared times sine x. You notice is the product of x squared and sine x. We put a raised dot in between, and again, we call it f times g. And we use the product. So to use the product rule, we need f prime, which is 2x, times g, just sine x. Then plus g prime, the derivative of sine is cosine, times f, which is x squared. We are done with calculus. Now, it's extremely important to notice this must come and sit in front of cosine x, because sometimes some students may mix up and think this is cosine of x cubed, which is not true. So 2x sine x plus x squared cosine x. Now we want to go to the quotient rule. So let's quickly look at the proof of that. So a couple of things. Number one, f over g prime, the shorthand notation is f prime g minus g prime f over g squared. The function that we want to differentiate is f of x over g of x. And we are going to go with the definition. F prime of x is limit of f of x plus h minus f of x over h as h approaches 0. So for this, what is capital F prime? Capital of f of x plus h minus f of x over h as h approaches 0. All right. So if you look at this fraction, you know f of x is this, you know h is that. So what is f of x plus h? Simply f of x plus h over g of x plus h. So I hope you see that this becomes this complex fraction. We're going to simplify a complex fraction by multiplying by LCD, which is the product of these two, g of x times g of x plus h. So we're going to multiply the top and the bottom by that. So first, I want to start from the bottom. Nothing happens. Write all of those. H times g of x plus h. What about the top? If you multiply these two, I'm assuming nobody has any problem simplifying a complex fraction. If you multiply these two, g of x plus h goes away. So f of x plus h times g of x. If you multiply these two, g of x goes away, minus f of x, g of x plus h. So a complex fraction becomes a simple fraction. At some point, we have to manipulate and bring it back to a complex fraction. Again, we are going to use a trick. We are going to add and subtract f of x times g of x. So we're going to subtract from here and then add to it. Now, we're going to put these two together and those two together. So pay attention to this part. I want to make sure everybody understands. First of all, the numerator, you see this h, I can keep g of x times g of x plus h at the bottom. This is algebra, everybody. I can put the h as the denominator for this one as well as this one. But I notice these two, they have a common factor of g of x. So I say g of x times what is left, f of x plus h minus f of x over h. I notice these two have f of x in common, and I'm going to put minus, not plus, because I want to take the negative f of x out. So I put minus f of x times this piece comes first, g of x plus h, minus g of x over h. So I hope you see that this is identical to this one. Again, this is a complex fraction. We are manipulating it. So having said that, the next step is to apply the limit laws. Apply the limit as h approaches 0 to every piece at top as well as the denominator. This one is just g of x. This one is f prime of x. This one is just f of x. This one is g prime of x. This one is g of x. This one is g of x. I hope you see that this is the g function. This is the g prime. This is the f function. This is the g prime. This is the g function. So is this one. So what do we get? because g of x times f prime minus f of x times g prime over g squared. And again, I put this in a f prime g, you see g f prime, that's the same thing. G prime f if f g prime. This is a proof. You're not responsible for it, but if you can follow it, it helps. Okay, everybody. We are going to move on. All right, we want to differentiate, and again, the first step matters, which is the only calculus step, and then there are several steps you finish it at home. So first, we notice it's a fractional format. We call it f over g. And we're going to use this. So we need y prime. We start with f prime. F prime is 4x cubed minus 6x squared times g, the bottom function, 3x squared minus 5x, minus g prime. The derivative of this one is 6x minus 5 times f, the top function is just itself, x to the power 4 minus 2x cubed minus 7. And then over g squared, just write this in the parentheses and square it. This is the only calculus step, everybody. It requires a few more steps to finish. You're going to finish this at home. Again, the platform, the digital platform may accept this as your answer, but it's not finished. So you have to finish this, especially you learn how to finish it using your algebraic techniques for the sake of the exam. All right, we want to differentiate y equals x squared minus 3x over x minus 1, and we're going to do everything from a to z, and we notice we have to use the quotient. So we're going to call it f over g. So y prime is f prime, which is 2x minus 3, times g, which is x minus 1, minus g prime, which is just 1, times f, the numerator, x squared minus 3x, over g squared, the bottom, in the parentheses and a square. Now, again, this is the only calculus step. Let me the asterisk next to it. And then you have a few steps to finish it up, and you must. So you have to FOIL this part. 2x and x is 2x squared, minus 3 and minus 1 is plus 3. It's the middle term. I hope everybody can easily do it in their head. This is minus 3x, minus 2x. These two add up to minus 5x. So we are looking at 2x squared minus 5x plus 3. This one just changes the sign. Minus x squared plus 3x. So the denominator remains unchanged, and you always keep it as a factored form. And the numerator, 2x squared and negative x squared, they add up to x squared, minus 5x, and 3x, they add up to negative 2x, and positive 3 remains. Now, the question is this the final answer or not? Anytime you have a fractional format, even whether you start from here or here, first, even here, you have to make sure it's in lowest term, because if it's in lowest term, it's easier to differentiate. And this one, is it in lowest term? Well, you ask yourself if there is a common factor between the top and the bottom, and if it is, it has to be x minus 1 at top, number one. Number two, How do we know if there is no way to factor this? I want to remind you of the quadratic formula. Ax squared plus bx plus c equal to 0. X is minus b plus minus the square root of b squared minus 4ac over 2a. B squared minus 4ac is called the discriminant because it gives us a lot of information. If b squared minus 4ac is positive, we have two distinct real solutions. The solutions will be rational if the discriminant is a perfect square and irrational otherwise. If b squared minus 4ac is 0, we have one solution only. One real solution is irrational. It's being repeated. If b squared minus 4ac is less than 0, we don't have any solutions. That is real. What do we have instead? Two complex solutions, complex conjugate of each other. A plus bi and a minus bi. Those are the solutions. And again, reminding you, if b squared minus 4ac is a perfect square number, then that expression can be factored. That's a very important. So those are piece of information from algebra. So let's take a look at the numerator. The numerator, a equals 1, b equals -2, c equals 3. B squared minus 4ac means -2 quantity squared minus 4 times 1 times 3. And this is positive 4 minus 12, which is -8. And therefore, it can't be factored out. It has to be a perfect square number, such as 1, 4, 9, 25, 100, and so on. And therefore, we are done with this question.